Hi everyone. Today we're going to study finding square root by division method. If a perfect square is a 3-digit or a 4-digit number, then each square root will have 2 digits. Let's see some examples. The square 100 and the square root is 10. This is actually the smallest 3-digit perfect square. What about 961? The square root is 31. And this 961 is the greatest 3-digit perfect square. Next square is 1024 and the square root is 32. This 1024 is the smallest 4-digit perfect square. The number 9801 is the largest or the greatest 4-digit perfect square, and the square root is 99. Then we generalize. If a perfect square is of n digits, then each square root will have n over 2 digits if n is even, or n plus 1 over 2 if n is odd. The use of the number of digits in square root of a number is useful in finding square root by division. Let's find square root by division method. Let's discuss this method through an example. Let's say find square root of 529 by division method. Step 1. We place a bar over every pair of digits starting from the digit at 1's place. If the number of digits in it is odd, then the leftmost single digit 2 will have a bar. In here, our number is 529, so we put 1 bar to the number 29 and 1 bar to the number 5. We can see that there are 2 bars here that represent 2 digits for the square root value. Then step 2. We find the largest number whose square is less than or equal to the number under the extreme left bar. In here, this is number 5. Note that number 5 is between 2 square and 3 square. But in here, we're going to take the base 2. We take this number as the divisor, and the quotient with the number under the extreme left bar as the dividend. In here, it is 5. So, let us divide and get the remainder later. So, this is what we'll do. We divide this 5 by the number 2. And the answer is 2. Then we multiply 2 times 2 becomes 4. When we subtract, we will get the remainder 1. Step 3. We bring down the number under the next bar. In this case, it is 29 to the right of the remainder. So, we have now the new dividend 129. Step 4. We double the quotient and enter it with a blank on its right. In here, our quotient is 2. When we double, it becomes 4. And then, we put a blank after number 4. We need a digit for this blank. Step 5. We guess a largest possible digit to fill the blank, which will also become the new digit in the quotient, such that when the new divisor is multiplied to the new quotient, the product is less than or equal to the dividend. We're going to do here trial and error. Suppose in the blank we write number 2, so we have 42. Since we write here 2, we're going to multiply this 42 by that same digit 2. 42 times 2, we will have 84. When we compare 84 by 129, this is much lesser. So let us see another number. Suppose we put 3 after the number 4. So this time we have 43. Since we write here 3, we are going to multiply 43 by 3. And the product is 129. And from here we can see that this value is equal to the new dividend. So in here we're going to choose the number 3. When we finalize and we write here number 3, same value 3 we will write on top of this 29. So the previous quotient of 2 becomes 23. Then we get the remainder. That means this 129 here we subtract by this new dividend and we get 0. And step 6, since the remainder is 0 and no digits are left in the given number, therefore we stopped, then we conclude that the square root of 529 equals 23. Example 2. Find the square root of 4096 by division method. Step 1. We place a bar over every pair of digits starting from the digit at ones place. If the number of digits in it is odd, then the leftmost single digit 2 will have a bar. Our number here has 4 digits. So that means when we group them, there's one bar on top of 96, another bar on top of 40. We find the largest number whose square is less than or equal to the number under the extreme left bar. In this case, we have here 40. Notice that 40 is between 6 square and 7 square. But in this case, we will use the number 6. We take this number 6 as the divisor and the quotient with the number under the extreme left bar as the dividend. Here is 40. So, we divide this 40 by 6. We will get 6. 6 times 6 is 36. Then when we subtract, we will get the number 4. The remainder is 4. Step 3. We bring down the number under the next bar, which is 96. So we have now the new dividend, 496. Step 4. We double the quotient and enter it with a blank on its right. The number 6, we double, it becomes 12, then there is a blank after the number 2. We need a digit here. Step 5. We guess a largest possible digit to fill the blank, which will also become the new digit in the quotient, such that when the new divisor is multiplied to the new quotient, the product is less than or equal to the dividend. So let's say for this 12, the next digit is 4. Since we write here 4, the 124 is multiplied by 4, and the product is 496, which is equal to the new dividend here. So we write and finalize the digit 4 here. At the same time, one digit 4 is coming after number 6. So the new quotient now is 64. Now we get the remainder. This 496, we subtract by this value 496. And the difference is 0. Then we stopped. Step 6. Since the remainder is 0 and no digits are left in the given number, therefore, the square root of 4096 is 64.